Okay, in this section, section 4, we're going to talk about something called the law of sines. Most of you, I think, saw at least an intro to that in geometry. Basically, what we've been doing up until now, like when we were solving for a triangle, we were finding side lengths and angle measures, but we were doing that in right triangles. So we're going to talk about a method that will allow us to solve a triangle, find all of its angles and sides, if it's not necessarily a right triangle. And we're going to do that using the law of sines. We're also going to learn a new area of a triangle formula. So look for law of sines, solving a triangle in ambiguous case. Those are the vocab terms that you should know. So here is our first concept for this section, which is the area of a triangle. This is a new formula for the area of a triangle. The area is 1/2, and I take one side times another side, so two adjacent sides, and then times the sine of the angle, but the angle has to be the angle that is included between those two sides. So for example, if I know side B and side C, I have to use the sine of angle A. If I know side B and side A, I have to use angle C because C is included between sides A and B. So that's why you see three formulae. Here's their really formulas here. They're really all the same thing. 1/2 times the product of two sides times the sine of the angle included between those two sides. So this isn't one way, an application of sine to finding the area of a triangle. So here I have a triangle. I know two sides. I know side B, 6 centimeters, and I know side C, 3 centimeters, and I know the included angle. So I can take this formula, 1/2 times B times C times the sine of angle A, and I can just plug in. B is 6, C is 3, and angle A is 25 degrees. And I just use my calculator, plug that in, and you should get about 3.8. Of course, you want to use correct units, so it would be 3.8 square centimeters. Make sure you don't forget your units. Okay, so you guys try that same thing with this triangle. All right, your answer here was C, which is 7 centimeters squared. All right, here's the work for that one. This one actually comes out to be exactly 7 because we know that the sine of 30 degrees is 1/2. So you could even be able to do this one without a calculator. 1/2 times 28 is 14 times 1/2 is 7. All right, now we're going to talk specifically about the law of sines. This is the second objective or the second part of this section. The law of sines shows the relationship between side lengths in a triangle and the sines of opposite angles. So basically the law of sines comes from the area formula. Remember, this is the area formula we saw in the first part of the video. 1/2 times two sides times the included angle. Basically, if I rearrange this, all three of those are equal to each other. If I rearrange this by multiplying everything by 2 and dividing by ABC, I end up with the law of sines. So here if I multiply by 2 and divide by sides ABC, my 1/2 becomes 1. BC over BC is 1, so I end up with the sine of angle A over side A is equal to the sine of angle C over side C is equal to the sine of angle B over side B. So this is the law of sines. So we usually see it this way, but you can write it either way. The sine of A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. This is the law of sines. This is in triangle ABC. Notice it is not necessarily a right triangle. It has angles ABC and opposite sides ABC, so this relationship is always true in a triangle. There are two cases where you can use the law of sines. Make sure you write these down in your notes because we're going to have to be able to distinguish between when we would start with the law of sines and when we would start with the law of cosines, which is what we'll see in section 5. So I can use the law of sines if my given information is two sides and one opposite angle. So they're showing me that here. I have side 49 and side 16. I do not know the included angle, but I do know an opposite angle. This angle 115 degrees is opposite of side 49. That's one case where I can use the law of sines. Another case is if I'm given two angles and one opposite side. So notice again here I have two angles, 29 and 118 degrees. I don't know the included side, but I know one side that is opposite of that angle. So make sure you write both of those down. Those are the cases where we would start with law of sine. So we're going to start with the case where I'm given two angles and one opposite side. Given two angles and one opposite side. So I'm going to solve this triangle. Solving a triangle means I solve for all three angles and all three sides. So I'm not done until I know all 6 pieces of information about my triangle. So the easiest thing to do is if I'm given 2 angles in a triangle, I should find the measure of the third angle because I know that the angles of a triangle add up to 180 degrees. So 100 degrees plus 53 degrees plus angle A has to equal 180 degrees. And when I do that, I get 27 degrees. So now I know all of my angles. I know that angle A is 27 degrees and the other 2 were given to me. Now I'm going to use the law of sines to solve for side A and side C. I already know angle A is 27 degrees. So I'm going to set this up. Notice I'm going to use the sine of B over B. Why? Because I know angle B and I know side B. The only thing I don't know and what I have set up here is side A, and that's what I'm going to need to solve for. So I have the sine of 27 degrees, because I figured out angle A, over A, that's what I don't know, equals the sine of angle B, 53 degrees, over 9. So I'm going to solve that for A. Here it is with another step shown. Basically, I multiplied both sides by A and then multiplied both sides by 9. Some of you know that is cross multiplying. And I end up getting A is equal to this ratio. And when I solve with my calculator, I get A is about 5.1. So A is about 5.1. So side A has a length of about 5.1. Now all I need to do is solve for side C. So I'm going to use the law of sines again. I know that A is about 5.1. Again, I know angle A is 27 degrees. So I'm going to use the law of sines. Again, I'm going to use sine of angle B over side B because I know that exactly. And I'm going to solve just like we did in the last one, and I get that C is about 11.1. We usually round to the nearest tenth for sides if we don't know their length. So altogether, I found my 3 missing pieces of information using the law of sines. So now I want you guys to try that with this triangle. All right, your answer here should be A. And there is how I solved for my sides. It was easy to get the third angle of 70 degrees because a triangle adds up to 180 degrees, all of its angles. Then I just used that information to solve for A and B using the law of sines. So this is how I solved for A. This is how I solved for B. Okay, so that's what happens when I'm given 2 angles and a side. When I'm given 2 angles and a side, there is only one unique triangle that can be formed if I'm given 2 angles and a side. But if I'm given 2 sides and an opposite angle, things can get a little more tricky. When I'm given 2 sides and an opposite angle, I could have no solution, 1 triangle solution, or 2 possible solutions. When there are 2 triangles, that case is called the ambiguous case because it could be one or the other and we don't know which one it has to be. So this chart is going to be super important to you when you're working on these kind of problems, okay? So we're considering a triangle where I'm given side A, side B, so I'm given 2 sides and angle A, which is the opposite angle, right? It's an opposite angle from side A. So if my given angle is acute, so if the angle I'm given is between 0 and 90 degrees, if this opposite side, so here it's A, if that opposite side is smaller than the height, then there's no solution because that side is not going to connect with the other side of the triangle if it's shorter than the height of the triangle. There's 2 ways to get one solution. I can have the opposite side that I'm given is equal to the height, in which case I have a right triangle. There's only one triangle I can make there. Or it's possible that A, which again is the opposite side from the angle, is greater than or equal to my other given side. So if my opposite side is greater than or equal to the other side, there's only going to be one possible triangle that can be made. This is the one, and it shouldn't say no solution, it should say 2 solutions. So please correct that on your notes, please, please. This is the ambiguous case. This is the tricky one. If my opposite side is smaller than the other side they gave me, but bigger than the height, then what happens is that there are two different places, two different triangles that I can make. I can make this triangle, right? Sorry, I'm not drawing it totally perfectly, but A could connect from here down to here, and that's fine. That's one triangle I could make. Or A can swing through and connect over here, and I can make this triangle. Notice that this triangle is an obtuse triangle, right? It has one obtuse angle. So that's what can happen. That's called the ambiguous case. If the angle that they give me is a right angle or an obtuse angle, I can only have no solution or one solution. So either the opposite side is less than or equal to the other given side, in which case there's no solution, or if the opposite side is greater than the other side, there will only be one solution. So the only way I can have two solutions is if my given angle is acute and my opposite side is smaller than the other given side but greater than the height. So let's look at a few of these examples. Here in part A, we're going to figure out whether or not this triangle has no solution, one solution, or two solutions, and then we're going to solve it. So let's take a look. You have the triangle there on your notes so that you can keep looking at it, and you should always be referencing back to your chart as well. So notice in this case, I'm given an angle, an opposite side, and just another given side. My given angle is obtuse, so I'm going to be looking at the right-hand side of the chart, and what's going to happen is it's actually going to be the second situation where there's one solution, because my opposite side, which is like A in the chart, is greater than B, which is my other given side. So since angle Q in this case is obtuse and 11 is greater than 8, I'm only going to have one solution, so I can use the law of sines. In this case, I have to use law of sines to solve for an angle. So I'm going to say that the sine of angle N over 8 is equal to the sine of 110 degrees over 11. I'm going to multiply both sides by 8, and I get this ratio. Then remember, to get n by itself, we have to do the inverse sine, and that allows me to get the degrees of my angle. So angle n is 43 degrees. Now I'm missing angle P. We already know angle Q, now we know angle n. So I can say, okay, angle P has to be 180 degrees minus 110 degrees minus 43 degrees. It has to add up to 180, so I know that angle P is 27 degrees. And now I'm going to use the law of sines to find my third side. So the sine of 27 degrees over P, now that I know angle P, is equal to the sine of 110 degrees over 11. So I get P is about 5.3. So there I used I figured out all three pieces of my missing information. All right, in this triangle, again, we're given one angle. This time my given angle is acute. Right, the other side that I'm given is 9 and the opposite side is 5. You can probably already see what's going to happen here. I have to find the height to see. It looks like, sorry, I was thinking they were already showing you, but they're not telling you what the height is here, so we have to figure out whether or not this side is less than the height or longer than the height. So to do that, I find the height using trigonometry. And I'm going to come back here to show you what I did. I said that the sine of 52 has to be h over 9, or opposite over hypotenuse. So 9 times the sine of 52 degrees gives me the height. And when I do that with my calculator, I do end up with 7.1. So I end up with a height that is longer than my opposite side. My opposite side is less than that height, so there's no solution here. There's no triangle. All right, we're going to, as quickly as we can, see if we can get through the case of two solutions. So in this case, I'm given a 28-degree angle, an opposite side of 9, and my other given side is 15, which in this case is z is 15 and x equals 9. So what I'm going to do, x is acute, and I can see that my opposite side is less than my other side. So now I just have to compare it with the height. I do the height like I did in the last example, just set up a trig ratio, and I end up with a height of 7. So it turns out that my opposite side, this is the two solution case on your chart, is between those two numbers. So there are two triangles to be solved. The first case is where angle Z would be an acute angle. This is always the one we do first. So we use law of sines to solve this triangle. Using the law of sines, I'm going to go through it relatively quickly. You might want to pause to write that down. So we do what we've been doing before, and then we simplify. The second case involves angle Z being obtuse, and we'll finish talking about that case in class tomorrow.